Welcome to Click Academic. We are going to solve some further examples on differentiation just to show you how it works. This is using differentiation using first principle, just to show you how it works. So, I have some very simple problems here that will guide you on how to solve further, more complicated problems. But for now, we just do these ones. So, the solution for, let's say, number 1, we have our f of x is equals to 2x squared. So, when our x changes by delta x, a small change, our f of x is now going to be, f of x plus delta x is going to be 2 into x plus delta x all squared. So now, since we have these two, we can just put them into the formula, which is dy dx is equal to f of x plus delta x. Let me just write it out so that f of x plus delta x minus f of x over delta x. This limits as delta x tends to 0 of this. So, limits as delta x tends to 0 of my f of x plus delta x is this 2 into x plus delta x squared minus my f of x is 2x squared divided by delta x. So, this, my dy dx is, when I open this bracket, first I square, then I open the bracket to include these two outside. So, it's going to be 2 into x squared plus 2x delta x plus delta x all squared minus 2x squared divided by delta x. Sorry, this is limits as delta x tends to 0. You shouldn't forget this. It's always very important. So, limits as delta x tends to 0. When I open this bracket, it's going to be 2x squared plus 4x delta x plus delta x all squared minus 2x squared divided by delta x. So from here, I have positive 2x squared, negative 2x squared. So these two are going to cancel each other out. It's going to be 0. So this means my delta x, dy dx, is equals to limit as delta x tends to 0 of 4x delta x plus delta x all squared divided by delta x. So my dy dx is my limit as delta x tends to 0. From here, I can see they have delta x in common, so I can factor it out. It's going to be delta x into 4x plus delta x divided by delta x. So it's going to be this. So my dy dx is simply limit as delta x tends to 0 of 4x plus delta x. So if I take my limit, dy dx is just 4x plus 0, which is 4x. So this is the differentiation of 2x squared. Keep that aside. For number 2, our f of x is equals to x cubed plus 1. So our f of x plus delta x is going to be x plus delta x all cubed plus 1. Meaning we replaced our x with x plus delta x. That's simply what we do here. So our differentiation dy dx is equals to limit as delta x tends to 0 of f of x plus delta x, which is x plus delta x all cubed plus 1. Well, let me use the square brackets. Minus my f of x, which is x cubed plus 1. All divided by delta x. So this means my dy dx is equals to, I open this my bracket. By expansion, we know how to expand brackets. Expansion, if I expand this bracket, it's going to be x cubed plus x squared delta x plus x delta x squared plus delta x cubed plus 1. We are going to have, plus 1. We are going to have 4 terms from the expansion, then plus the 1 outside. Then minus, if I open this bracket, it's going to be minus x cubed minus 1 divided by delta x. Limit as delta x tends to 0. So my limit as delta x tends to 0 of this, I'll just open the bracket now, x cubed plus x squared delta x plus x into delta x all squared plus delta x cubed plus 1 minus x cubed minus 1 divided by delta x. So I have positive x cubed here, I have a negative x cubed here, I have a positive 1, I have a negative 1. So this means my dy dx is simply my limits as delta x tends to 0 of what's left, my x squared delta x plus x delta x squared, then plus delta x cubed. Sorry, I have a 3 here. I also have a 3 here. There are 2 3s here. So here I'm going to have 3. I'm going to have 3 here also. Divided by delta x. So my dy dx is equals to limit as delta x tends to 0 of all these have the x in common, delta x rather. So my delta x will come out into 3x squared plus 3x. Since I've taken one delta x, it's going to be delta x plus delta x squared divided by delta x. So my delta x will take this, my delta x will take this. So this implies dy dx is simply my limit as delta x tends to 0 of 3x squared plus 3x delta x plus delta x squared. So when I take my limit, it's just going to be dy dx is equal to 3x squared plus 3x times 0 plus 0 squared. Since I've taken my limits, I'll take that delta x tends to 0. So I'll just rewrite this as 3x squared plus 0, which is just 3x squared. So this is differentiation for the second one. For the third, it's a bit more tricky. We need simple knowledge of trigonometry. So when I say my f of x is equals to sine x, so my f of x plus the x, delta x rather, is sine. We replace my x with x plus delta x. It's going to be x plus delta x. So dy dx is equal to my f of x plus delta x, which is sine x plus delta x minus f of x, which is sine x, divided by delta x. Limit of this computation, or whatever you want to call it. So my dy dx is going to be from here. Let's strike this out for a minute. From here, I have an identity, a trigonometric identity, saying whenever I have two sines, let's say sine of an angle A, subtracting sine of an angle B, for instance. So this is from trigonometry. When I have this, I can just rewrite this as, I'll say this is 2 into cos A plus B divided by 2 times sine A minus B divided by 2. This is a simplification. This is a simplification of this. So we have to use this identity to simplify before we're able to get the answer. So my dy dx is just limit as delta x tends to 0 of, so in this case, my x plus delta x is my A, and my x alone is my B. So I'm going to replace this whole thing with something similar to this. I'll just replace my A with x plus delta x and my B with x. So it's going to be limit as delta x tends to 0 of 2 cos, my A is x plus delta x, right? Then plus x, which is my B, divided by 2, times sine, my A is x plus delta x, my B is minus x, 2, divided by delta x. So I'll just simplify what's in the bracket. Limit as delta x tends to 0 of 2 cos. When I open this bracket, it's going to be 2x plus delta x divided by 2 times sine x minus x is 0. So this is just going to be delta x divided by 2, all divided by delta x. So my dy dx here is limit as delta x tends to 0 of 2 cos. So I can say this is 2x divided by 2 plus delta x divided by 2 times sine delta x divided by 2, all divided by delta x. So my dy dx is still, all this is simplification, delta x tends to 0 of 2 we'll take 2. So this is 2 cos x plus delta x divided by 2 times sine delta x divided by 2 divided by delta x. So from looking at this now, I can simplify it further. I can make it look how I want it to look. All I'll do is I'll say dy dx is equals to, I move this my 2 now. I'll say it's equals to cos x plus delta x divided by 2 times sine delta x divided by 2. This is times 2. Because we know that's what this 2 is. I can put this 2 here, I can move it, so this is going to be 2. Then I move my delta x to the 2. So this is allowed. Limit as delta x tends to 0 of this. This is allowed. So my dy dx is just, now I can rewrite this again. I'll just say this is cos limit as delta x tends to 0 of cos x plus delta x divided by 2 times sine delta x divided by 2 divided by delta x divided by 2. And we know also that I can give this delta x divided by 2, I can put it under my sine, I can put it under my cos. Whatever works, the cos and sine are multiplying each other. So I can put it under any one, it will work the same way. So this means that my dy dx is equals to cos x plus delta x divided by 2 times sine delta x divided by 2 divided by delta x divided by 2. Sorry, this is my limit. I can rewrite this as this. So from our knowledge of limits, algebra of limits, this is limit as delta x tends to 0 of cos x plus delta x divided by 2 times limit as delta x tends to 0 of sine delta x divided by 2 divided by delta x divided by 2. So also we have a rule, we have something, a guideline sort of. It says when I have limits as, for instance, theta tends to 0 of sine theta divided by theta, see this, the angle and the denominator are the same, this is just equals to 1. This is the guideline, this is equals to 1. So looking back at this, we have the angle dx divided by 2 is divided by dx divided by 2, and limit as delta x tends to 0. So this whole sign part will turn to 1. So this is equals to my limit as delta x tends to 0 of cos x plus delta x divided by 2 times 1, which is, when I take my limit, this is just cos x plus 0 divided by 2, which is just cos x. dy dx is equals to cos x. So when we differentiate sine x, we just get cos x. So that is how we differentiate from first principle.